Hello. Yeah. Hi all. So today we'll continue solving Leetcode DSA questions in Java. These are specific to Goldman Sachs. Like these have been asked in Goldman Sachs. So yeah, let's let's start solving. Solving Leetcode DSA questions. Okay, let's get started. So I've already solved the first three in the evening, so I'm continuing with the fourth one. We have some 11 questions here, so let's try to solve all of them. We are done, so we have 8 more to go. Let's go. What is the question? Fraction to recurring decimal. Okay. Given two integers representing the numerator and denominator of a fraction, written the fraction in string format. Given two integers. Wait a minute. Given two integers representing the numerator and denominator of a fraction. Okay. Within the fraction in string format, if the fractional part is repeating, include the repeating part in parentheses. Okay, okay, okay. So we have done this question few days back. Let me just try to solve it in that format itself. Now, what we have to what we have to check is if multiple answers are possible within any of them. Okay. One thing for sure is if numerator is equal to 0, I can simply return 0. So this is some base case or edge case. Okay, so let's just get done with it. Now there are multiple scenarios. Okay, one scenario is something like 1 by 2, where your numerator is smaller. But we also have a scenario of 15 by 7. So numerator is bigger, but still it is a decimal number, right? Which means that I should handle wait, I should handle numerator when it is bigger than denominator initially. Like for recurring stuff we might need a loop, but if numerator is greater than denominator, then we don't need a loop. We know that 15 by 7 will give me 2.5 is there. Sorry, it will give me uh, 15 by 7 is 2.142 something, but okay, we will first get 2 and then some XXXX digits. Okay, so let's first take care that 2 is present in our result, our resultant string. So let's do sp dot append and we do numerator by wait. Uh, so we have numerator by denominator. I am taking it in an integer because we just want integer value, and in here I will do integer dot parse in that. Okay, so now I have appended. So now I have 2. Now I also need the decimal, correct? So let me also add the decimal in here. Let me add the decimal. Uh, sb dot append this. But what if it was a proper division? Okay, so what I also need to do is when I divide 17, suppose if it was 14, 14 by 7 means 2, correct? So when I do 14 by 7, what I have to do is I'll update numerator. You can also take a separate variable, but if we update the numerator itself, we'll update numerator with val, right? Wait. Or wait. One thing we can do is basically, let me check. So if we have uh, if we have something like 14 by 7, we want to return 2. Okay, so that is taken care of. Now I want to ensure that the division is done. So I can check the the remainder goes to value. So yeah, I can take a remainder. So we can take numerator mod denominator, and here I can check that if uh, remainder is equal to 0, which means we have perfectly divided, then we can return sp dot to string. Okay, we have to return a string. This is a string builder. Now, remainder was not equal to 0, so in like 15 by 7 case, uh, remainder will not be 0. Uh, like so, remainder will be 1, and then we take a decimal, and then we have to do the regular divide thing. Okay, so how to approach that? Basically, we have to divide as well, and also we need to take care of adding these brackets. So let me copy this. Uh, let's check. Wait, let me add the question number in chat as well. Solving this question. Okay. So now, we have appended the decimal. So decimal is there. Decimal is present. Uh, Now, what should we do? So basically, um, uh, okay, yes, yes. So basically, since for see, if we have some recurring remainder, we have to enclose it, right? We have to enclose it. So we should take care of we should take care of um, this remainder. So what we will do is we will have a hash map which would store the which would store the remainder and the index or the position of that remainder. Okay. So yeah, we can do this. So yeah, okay. While remainder is not equal to 0, what we can do is um, basically we would add remainder, and we will add the index as well, that at which index I have received this remainder. So right now remainder here was 1. Okay, remainder here was 1. Remainder was 1. So what I'm trying to do is empty dot put, we are putting the remainder, as well as what is our SB length. SB is something like 2 point. So SB dot length, we are adding it in here. Okay, and since obviously it is a decimal, so we can do this because now like once it was 10, now it becomes sorry, once it was 1, now it became 10. Okay, and then what we have to do is we have to uh, append remainder by denominator, and then remainder is equal to 10, basically whatever the not 10 or denominator, like we have 15 by 7, so we have 15 by 7. Okay, we are taking care of the remainder. We have the remainder here as remainder was 1. What we did in hashmap was we added 1 and sv dot length of 2. Now in we are doing remainder equal to 10 because we have added the decimal, and now our denominator was 7, so 10 by 7 will give me 1, so 1 is appended here, and then remainder will again be mod of this. So when we do 10 mod 7, we'll get 3. So now remainder will become 3. So while remainder is not equal to 0, yes. Now we also have to add the logic to check if it's a recurring remainder. Now that's what we'll check here. If map already has this key, it means we have encountered this remainder before. And once we encountered the same remainder before, that thing this thing will keep on repeating. That is why we are taking care of the we are pushing basically these parameters into a hash map. Okay, and we are also taking care of the position. So here, okay, let me take a different example where we can get this scenario. So okay, here what I'm doing is if numerator is greater than denominator, but if you have something like 4 by 9, 4 by 9, we will not enter this 2 and this remainder will not be initialized. So this is a bug. I need to take care of this scenario. Um, Actually, we don't need this because see, even if it is 1 by 2, we are appending 0, right? So in any scenario, I'll have to append this 0. Okay, so yeah, now this is fine. Our remainder will be initialized as numerator not denominator, which is 4. So remainder would be 4 only, right? Yeah, 4 only. So remainder is 4. So remainder is 4. Uh, we have something like 0 dot. We have something like 0 dot. Okay, and remainder is 4. Map does not have anything as of now. And now we are checking remainder not equal to 0. Yes, map dot put remainder and sb dot length is 2. Remainder into 10. So we are doing 40 into 10 decimal means since we have added the decimal, we can add as many zeros. And now in string, in our resultant string, I am appending this 40 by 9. This will give me something like 4. Okay, 4, right? Yeah, 9 to the 36. And then I'll again have 4. Okay, so remainder will again become 4. Now, empty contains this key. Empty contains this key, which means I'll have to add brackets in front of it and at the end of it. Okay, so I need to find the index where I need to put the brackets. So one is M, right? So here for 4, 2, so 0, 1, 2. This is the position. This is the position where the bracket should come up, right? So we simply do sb dot insert at idx. We insert this, okay, and at the end append this, and then we return sp dot to string. What is the issue? Int cannot be converted into string. Integer dot parse int. This is integer, no? To string. Wait. Integer dot to string. Int can't be converted to long. Achha, we have taken long here because this. Achha, okay. Our numerator or denominator may be negative as well. So what we can do is, if basically either one of them is negative, if numerator, if either one of them is less than equal to 0, and denominator is greater than 0. If numerator is less than 0 and denominator is greater than 0, or numerator is less than 0 and denominator is greater than 0. Actually, a better way of writing this, if you understand the pattern, is XOR. Numerator less than 0, right? So either one of them needs to be, and this would be denominator less than 0. So let me also add this in a bracket. Then what we can do is sp dot append minus, yeah, and yeah, the issue was we were getting. So let me just use long. Will this work with long? Int cannot be converted to long. Do we have something like long or two string? Okay. Array, wait. We should do it like this. Long num, long val. Yeah. Let's just try appending val. Missing return statement. Okay, my bad. We need to return c dot position. I don't know. Actually, essentially, we should be returning to this position only. Yeah. Okay. Let's try submitting it. Are we missing any SSH? Let's check. Wrong answer. Why? We have appended two minus. Why? Okay. I got it. Actually, let's see. Basically, uh, this division will also provide that minus to us, right? But let's check. Let's check it. Hmm. Okay. Another test is failed. Minus 50 of it. Okay, I think see, better approach is to like here we are appending minus, that is fine, and after that we can deal with the absolute values. Okay, and let's just also do the conversion here. So we'll just say long numerator is uh, math dot absolute of long, sorry, long numerator. So what we are essentially doing is uh, taking only the uh, positive value, because we are taking care of sign separately. Okay, so what I have to do is to the sorry, there are only two occurrences of numerator, so let me make it num. Denominator, let me make it 10. Or yeah, this will also be 10. Yeah, it should work now. Most probably it should work. Let's check. It's a it's it's a good question actually. Hmm. Okay. Just to uh, uh, you know, uh, just to give a gist of what we did here was, sorry, just to give a recap of what we did is, if numerator is 0, we are simply returning 0. Otherwise, if any of the numbers is negative, if like one of the numbers is negative, only then we are appending a minus, and then we are taking the absolute values so that we don't have to deal with minus again. And initially we are calculating whatever the value is by dividing, so that we get the numeric value, whatever we have to add in here, and we are appending that. After that, we are taking the remainder and we are dealing with the remainder. If remainder is equal to 0, we can simply submit, or even if even this we will take care of that, and we can just return the string. Even if we don't add this, that is totally fine. But okay, we are doing this, right? So it's good to have it there itself. And then we are appending a decimal. It means that we need a decimal and we need some extra zeros. So we add a decimal, and then in this hash map we are storing the remainder and the position where we got that remainder, so that we know where to add that starting bracket, starting opening bracket. Okay, so yeah, so we are maintaining a hash map of that position, remainder towards the position. Also, once we get the same remainder again, we know that it is a recurring step. and we just insert index at index the opening bracket and at the end the closing bracket and return it. Otherwise, the calculation is simple. We calculate the we basically remainder serves as a new divisor every time, right? So remainder into equal to 10, and then we figure out the remainder again and append the quotient to the answer and figure out the remainder again, right? So yeah, we have solved it. So let's move on to the next question. Fraction to recurring decimal is done. We have done one, two, three, four questions. Okay, first unique character in a string. I've solved these questions like few days back only. Okay, but it's important to revisit the questions sometimes because in the first, when you're solving it for the first time, you may not actually grab the logic. You know, with spaced repetition, you kind of start identifying the patterns. That is why. Let me reset. Yeah, okay. Now we are solving this first unique character in a string. What is the question? Given a string S, find the first non-repeating character in it and return its index. If it does not exist, return -1. You have to return the first non-repeating character. First non-repeating character. Okay. So whenever this kind of uh, frequency stuff comes up for any string, the only way is, or like a good and optimal way is to use a frequency map. So yeah, what we can do is, no, wait, this will be 26. So I'm creating a frequency map. I'll iterate through the string char array. You have a char, and now in frequency, I'll go and I'll mark it as plus equal to 1. So I'll increment the frequency. So what after this, what I'll get is I'll get a frequency array in which L's position will be marked as 1, E's position will be marked as 3 because E has occurred twice, T 1 and similarly CD. Now the question is I have to return the first non-repeating character in it in the string. Okay, not in the frequency array. In the string, what is the first non-repeating character? So non-repeating character basically means that its index should be 1, definitely, right? So again we iterate through this, and we what we can do is we can say okay, I have to return the IDX. So let me just say index is -1 because if we don't get anything, we have to return -1 anyways. So char C to array if frequency of C minus 8 is equal to 1, immediately return. I need the frequency, right? Wait. I need the index, sorry. So I have to iterate through that index of I thing. Int I equal to 0, I less than n, I plus plus, and then I can say char C is equal to char C is equal to h dot char at I. Yeah. So now we can, yeah, wait. Frequency of, we have to return I. Yeah. Yeah, okay. So, I mean, this will get submitted, of course. This is a very simple, easy question. What I'm thinking is, do we have any other approach to this question? I mean, right now it is two pass. I'm iterating through the string twice. Is it possible that I iterate through the string once from the rightmost position? Can we do that? Wait, I'll take IDX or whatever the stuff I have to return as n plus 1, and I'll try to iterate through the string, but from the end. I will try to iterate from the last position. I greater than equal to 0, I minus minus, which means I am at E. I'll update char c equal to s dot char at I. I'll update its frequency to 1 and then I'll say if frequency of this is 1 after updating, then this is this is my suitable candidate, right? Like this may be an answer, maybe an answer. For now, I'm saying that this may be an answer if its frequency is 1. Okay, okay. So let's do one thing. I'll say care answer, something like this. So I'll say here, wait, yeah, I'll say here answer equal to C, and I will also get the index. Right? So I'm saying this may be an answer. Okay, which means when I start, I get E. Okay, so care is E. I go inside frequency array. I mark E as 1. E as 1. And here I check, okay, frequency is 1. So this may be an answer. So that means answer has, sorry, answer has E. E, okay. And IDX index has, we have updated, so like 0, 1, 2, 3, 4, 5, 6, 7. Okay, now again, we move ahead, we encounter D. So character becomes D. We come here, we mark D as 1, and answer becomes, sorry, and then we check, is it frequency 1? Yes. Then this, now we are always picking up the most recent element because then index will decrease, keep on decreasing, right? So index is 6. Now O, we come at O. So again we add O as 1, we check it is 1, so it also can be a potential answer. So let's just update. Then we get C, same stuff for C, it can be a potential answer. So C and I index will become 2. Now T. Again we repeat the same stuff. T, this can be T, and this is 3. Then comes E. Now we are dating, but frequency is not equal to 1. Frequency is not equal to 1. So it cannot be our answer. Then we come across L, and again same thing happens for L, and we are able to determine. Let me try running this. Uh, are we missing some edge cases or something? Let us just check. But if index stays at n plus 1, this means, okay, wait, there is one issue. There is one issue that suppose if it was L L E E T2, okay? So when we come at this L, it's good. Our index will update. But what if we do not we do not uh, like for this L, we will not come inside the loop, but still answer and index will point to this index, right? Which is wrong. So maybe we can add an else loop, and that would say if frequency. Else basically means that frequency is greater than, right? Frequency is greater than. At that point, what we do is we unmark this answer. We unmark this answer, okay? Which is now this should be fine, I think. Let's see. Let's see. Because frequency will either be 1 or it will just increase, right? What happened here? Okay, my bad. Empty character literal. Empty character literal. So let's just have character. I think we can remove this because we are mainly tracking the answer via IDX. We are not actually using this. Okay, answer. So let's just remove it entirely. That was mainly for our understanding purpose. That is giving -1, but expected is 2, 0, 1, 2. Else, if the frequency for this element is this. Okay, right. Right. So does this mean this approach will fail? We cannot do it in single pass. I let's check. Right. Actually, basically with a single pass, we are not able to confirm the uniqueness, right? Whether a character is indeed appearing only once. That is why it is tricky. So okay, we can do it in single pass using the queue. How will a queue help us? We have this. Let's create a queue. The queue is equal to new linked list. So we have a queue. We get the current character, we increment it, yeah, and also in queue we add this index. Okay, we're pushing the index of the candidate, and then what it does is not queue dot is empty. Yeah, sorry, queue dot keep minus this greater than one queue dot full. Basically, what we are doing is we are adding the index to the queue. So we add the index to the queue, and we are checking, and we are basically removing it from the queue if it's not unique, if the stuff is not unique. Anyways, I think the our solution of two cars is totally fine. We don't probably need this solution. So let's avoid confusing ourselves. Let's move on to the next question, which is design hash map. Okay, it's a good question. It's a good question. Design hash map. Solving which question are we solving? Which question are we solving? Design hash map. Solving 706 design hash map. Okay, I solved it before submissions. May 13, 2025. Okay, let's see. Design a hash map without using any inbuilt hash table libraries. Okay, implement the myHashMap class. MyHashMap initializes the object with an empty map. Void put inserts a key value pair into the hash map. Okay, if the key already exists in the map, update the corresponding value. Okay, int get int key returns the value. Okay. Now here the constraint is for the key. The constraint is up to this 10 raised to the power 6. Basically, what I'm thinking is of taking an array of this size so that we can directly add it to the key. Like we'll have that key, right? If we have this big array. Okay, sorry. So let's do that. Okay, let's make a private variable which let's call this sorry, let's call this map, and in here I'll create a map of size 1 2 3 4 5. 6. But let's give a 1 here because we can have the value can be up to 10 raised to the power 6, so we need to adjust it and have 10 raised to the power 7. Sorry, raised to the 6 plus 1. Okay, now uh, my hash map is initialize the object with an empty map. So yeah, I mean, we don't need to actually do anything. Let's just have it like this. Void put in t in the value inserts a key value pair into the hash map. If the key already exists in the map, update the corresponding value. This is very easy. This is very easy. If you're getting a key, we'll say map or we will say this dot map of key is equal to value. Now even if we have to update, we will simply update. Int get int key returns the value to which the specified key is mapped or -1 if this map contains no mapping for the key. Okay, here I need to think a bit, but I have to think because if they're initializing, everything will be initialized with 0. Okay, 0. So let me do one thing. Let me initialize it with -1 so that I can figure out. So arrays dot fill map with -1. So when I am initializing, uh, I, I initialize my map with -1. So here what I can do is I can simply return this dot map of. So if it exists, it will return the value. If it does not exist, it will return -1 because that is what we have by default. Void remove key removes the key and its corresponding value. The map contains the mapping. It's very easy. Return. Sorry, I don't have to return anything, but this dot map of key should be equal to -1. Okay, am I missing something? Let's just check. Okay, it's working totally fine. Let me just submit it. I'm not sure. Is it really so simple? Okay, but let's go through the approaches given, other approaches provided in discussion or in the solution section because this was a very easy way to tackle it. Okay, let's see what others are doing. Let's see. Hmm, People who watch the writing video and still struggling. I just think that I'm gonna look at and rehashing the design. Okay, what is expected runtime? Maybe the hardest question. Should still be just because it's trivial to tease it. Exactly. This thing has really solved like 99% of the stuff. Yeah, we should try and implementing a good hashing method. So let's go through more solutions because it is an interesting question, right? So let's see. Okay, we have the editorial as well. Okay, we don't have the editorial. So Java custom hash extension, easy solution. I don't want the easy solution. I call it easily. So actually, in if we try to actually solve a design a hash map, we need to take care of multiple things. We need to take care of the hashing algorithm as well, right? So that is the step. Which is, what they are doing is they have taken a pair, a list pair buckets. Okay, this looks like an actual implementation. Okay, so I'll go through this some other time. Let me see. Hash, yeah. Okay, let's move on to the next question because this this can actually be an LLD question as well, and we can have a very long discussion on this. And to be true, I've not read through this, like gone through this earlier, so it would just consume our time. So for now, let's just add it to our revisit list, and we will revisit when we will revisit. We will not use this trivial hack of creating an array. We will have to actually design it. So yeah, let's move ahead. Twosome. Yeah, I have solved twosome today itself, so let's not solve it. Longest substring without repeating characters. Longest substring without repeating characters. Hmm. I don't know. I think this is a hard question. Is this a hard question? It's a medium. Okay. Hmm. Longest substring without repeating characters. Submissions. I solved this as well 2 days back. When have I solved it? 13th May 2025. 13th May. Okay. So it's been some time since I've solved this question. Let's go through it. Given a string as find the length of the longest substring without duplicate characters. Longest substring. Substring means contiguous, right? Substring means contiguous. So let's try using that property. We have A, B, C, A, B, C, B, B. A, B, C, A, B, C, D, D. With a length of 3. So obviously it has to be contiguous, right? And let's take the last example. P, W, W, K, E, W. So we have 3. W, K, E. Okay. Uh, See, whenever I see the word substring or subarray or something which indicates that it has to be contiguous, I try solving it via sliding window. So I'll try that approach of using sliding window for that, for this question. Now, how can we use sliding window? Let me just think on it. Basically, L is 0, R is 0. Basically, we have something like uh, like P, W, W, K, E, W. Okay, so if we start, um, we have to ensure that, okay, we're starting at this index 0, 0 or 0, and let's see that we have a map as well. Now what we do is we insert P. So we check that our map does not have P in it. So okay, let's insert P. So we insert P in our map, and then this can be a potential answer. So we calculate it as a potential answer and mark it. Now we move our right pointer to W. So our right pointer is now here, left pointer is here, and right pointer is here. The rest is now 1. Okay. Now the right pointer is at W. So here, what I'm doing is I'll insert W in the map. Before inserting, I'll check is it already present in the map, or wait. I'll insert it and then after I can check. Okay. So first we'll insert it in the map and then I'll check what is its frequency. Is its frequency greater than 1? No, it's not 1 greater than 1. Which means this also can be a potential answer. So we'll increment our result to basically result is calculated as r minus l plus 1 comma result. So max of these two stuff. So it comes as 2 and we increment our r pointer to this. Now as soon as we come here, we again update our map and we get WS2. And now when we check is its frequency greater than something? Yes, frequency is greater. Which means now as frequency is greater, we need to reduce the window size. Which basically this means that this window is now no longer a applicable or a valid window. So let's shrink the window size. So how can we shrink the window size? We'll increment L and accordingly we will update our map as well. So if we increment L, P will get removed from our map. Okay, we can remove it, or yeah, I think we can simply just Like we can simply decrement its occurrence, that is totally fine. And then we increment L. So now our L comes to W. Now also our problem is not solved and it stays an invalid window. So this would be a while loop which continues checking until the R is a valid window. So again we verify and now L and R are both on the same position. Okay, so L and R are both on the same W index. Okay, and after this we are checking. So this is a valid window, but we do not update our result. Now we increment R to this. Okay, again we check this is a valid window. We add K to our map. Okay, and we verify again. K is, occurrence is not greater than 1. So then we move ahead. Uh, we take this as a valid window, but 2 is equal to 2, so no need to update or do anything. Again we move R. So R now comes up here, and now this also comes as a valid window. So yeah, this is the basic process. Let's just code it out. Uh, let me just code it out so that everyone is able to understand. So we're taking low. So initialize left and right both at the starting index, right? And let's also initialize a result 0. And now while low is less than R, also we need a hash map. So let me just initialize that as well. So map of character comma integer, MP is equal to new hash map. This one, yeah. Now what we are trying first, we are inserting the character into the map. So let's just do np dot put. Oh wait, let me just take the current character, which is s dot char at r. So what we are doing is np dot put current, and here we are doing np dot get or default. So if current does not exist, if current exists, get current or default to 0 plus 1. Now here it would be a while loop which will check np dot get current is greater than 1. Okay, only then. So we'll handle that, but other than that, here we will do max of plus comma r minus I plus 1 and r plus equal to 1. Now here, while np dot get current uh, is greater than 1, what we have to do is current is this caret r. So yeah, what I have to do is I have to constantly reduce the window size. Reducing the window size basically means that np dot get, or let me do the char c. This will be s dot char at l. So since we have to reduce, we can only reduce from left. Okay, we will not remove anything randomly. So np dot get uh, c, and yeah, wait, sorry, np dot, we can do something like np dot put c comma np dot get c minus 1. So obviously, if we have inserted it once or twice, we'll decrement it in it less than equal to those number of times. So this should not go negative, but even if it goes negative, we are not concerned because we are checking this condition. Okay. So np dot put c and np dot get c minus 1, and then we do l plus equal to 1. So we go ahead, then again stuff, and then yeah, after that we simply return result. It should work. Let's see. Wrong answer expected since 0. Why? While np dot get current is greater than 1. While low is while L is less than R, np dot get or default. So we are getting 0 defaulting to 1. What is the issue here? What is the issue? What is the issue? Array wait. This would be while R less than N. Sorry, my bad. Yeah, this is totally fine. Yeah, accepted. Yeah, close to 1,000 test cases, but yeah, this is totally fine. Uh, so time complexity is O of n because we have one while loop, right? Inside it also we have another loop, but that is That will uh, at max it would also be offline times only, right? Time complexity will be offline, and space complexity will be again we are utilizing some space to store the hash map. So at max we will store all the unique characters, right? Now how many unique characters I can have depends on the problem description. We can have English letters, digits, numbers, so whatever we count is almost around that those many those many characters I can have. So we can say it as O of one because we may have 128 ASCII characters, but again that should be fine. Okay, let's move on to the next question. Kth largest element in an array. Kth largest element in an array. Okay, so what is the question? Given an integer array nouns and an integer p, written the when did I last solve it? May 27, 2025. I solved it in 2025. Okay. Given an integer array, okay, and in integer case, these are the kth largest element in the array. Can you solve it without sorting? Kth largest element of the array, not the kth distinct element. Okay, kth largest element. Okay. So to solve this, what comes to my mind immediately is priority queue, right? Because in priority queue we can store the elements. Now since I need the kth largest element, let's just say k is 2 for this question. Okay. Now I need the kth largest element. Okay. Actually, largest makes it seem like we need a max heap, but we actually need a min heap here. Because in the min heap, see, if I have a min heap and I need the kth largest element, so what I'll do is I'll try to maintain my min heap of size k only. Okay. Which means I get 3, I insert. I get 2, I insert. But now when I get 1, I'll not insert 1. Why? Because 1 is 1 is because that would be the third element, right? We only want two elements. But how to manage? Like how to manage which of these should I keep? So what I'll do is what we can do is to take a main heap, it will always give me the smallest element, right? So what I'll do is I'll first add the value, add the incoming number, and now it is greater than size is greater than k. So do one thing, keep on removing. Now nil heap removing means nil heap will remove one. It will remove one, so we will be left with 3 2. Again 5 comes. Add 5, but size is greater than k. Remove something. So we will remove the smallest, or nil heap will remove the smallest. So 2 comes out. Okay, so we have 3 5. Now 6 comes. Add 6, but size is greater. Remove the smallest. Remove the smallest. So 3 was removed. Then 4 came. Again, size is so it will remove 4. Then it will remove the smallest. So we have left with 5 6, and then we just return the topmost element. So yeah, that is why we are requiring a nil heap here, using a nil heap here. So yeah, I just want to store the integer, nothing else. So it would be priority queue, and this is by default on min heap, and we'll iterate we don't need the index, so let's iterate it like this. And now we are saying what we are saying is p2 dot offer num. Now here we are saying while p2 dot size is greater than k. Also one more thing, not p2 dot is empty. Anytime whenever we are running code, we should run this. We should have this check. P2 should not be empty. Not P2 dot is empty and its size is greater than k. What we have to do is we have to code. That's it. That's the only thing we have to do. And then at the end we can return P2 dot p. Yeah, very good. It is the code is of line like 16 lines. Good. But I think there are other approaches to it. CTO was simply using, like priority queue is simply using a data structure. Let's see what other approaches is being here. Divide and conquer. Yeah, I mean, whenever you have been given to find position, you have to find the way and to find care the smallest, max heap, and care largest in doing it. Yeah, this is a good, this is a good thing to remember. So I'll add it to my cheat sheet. Yes. To find care smallest element, we can use max heap, and to find their largest element we can use min heap. Okay, this problem is medium because it has a non-intuitive approach to solve it in O of n. What is the time complexity of this code? Let me check. Here we are just iterating through this once. Offer runs in O of log k, where k is the size of our heap, and this also works in sorry, works on O of log k, and this is O of n. So it's like O of n log k. Yeah. So TC is O of n log k. Space complexities will at most have k elements, so just k. Yeah. Okay. Since this is O of n log k, then that is why there is a more the quick sort approach would something be called like quick select approach will be called like O of n. Yes, that has given that is as you are going to this I thought about sorting this measure in this I map the frequency of all the number and then find the k largest number. Binary search. In this, I applied binary search between smallest and largest element, and for every mid, I calculated the number of larger element after the equal to minus 1 to the end and start the search phase. The problem is also that we have time nearly speedy elevator to me Nirvana. First, I remove his transcript, so I can to set the rules. Ninety-nine percent questions in need to use the word case. Largest, smallest, closest. When you see question, so smallest, yeah. This is a summary. We have the quick select approach here. Should we quick select approach? Can someone explain the quick select approach? Okay, let it be. Then go to the quick select approach. the next time we are approaching this question. And now let's just note it down and move ahead. We are done with this. We are done with this. Let's open this. Open the lock. I think it is a premium question. I think so. Let's see. Okay, it is not a premium question. Then it is a new question which are not solved earlier. Let's go through it. Open the lock. Open the lock. So you have a lock in front of you with four circular wheels. Okay. Each wheel has 10 slots. You have a lock. Okay, okay, okay. That is like that. The puzzle game locks. So yeah, we have four circular wheels. Each wheel has 10 slots. 0, 1, 2, 3, no? Wheels can rotate freely and wrap around. For example, yeah, you can from 9 you can go to 0, from 0 you can go to 9. Each move consists of turning one wheel, one slot. Okay, okay. Lock initially starts at 0, 0, 0, 0, a string representing the state of the four wheels. We are given a list of dead ends, meaning if the lock displays any of these codes, the wheels of the lock is stuck running and will be unable to open. Okay, so these are the dead ends which have been given to us. Given a target, given a target, given a target representing the value of the wheels that will unlock the lock, return the minimum total number of turns required to open the lock. Given a target representing the value of the wheels that will unlock the lock. Acha, okay, this is basically the code, the actual code. Okay, so when we use this, our lock will get unlocked, but we have to come to this without going through any of these scenarios. So given a target representing the value of the wheels that will unlock the lock, return the minimum total number of turns required to unlock. Okay, so we need minimum number of turns. Okay, uh, seems like a good question. Let's see what we can do. So target is 0 to 0 2. We are at 0 0 0 0. I don't know. It seems like a DP where I have to simulate all the possible, scenarios. And whenever we approach a block scenario, we'll just bypass that. What it is here, we can turn the last wheel in reverse to move from 0 0 0 to 0 0 0 9. Okay, 0 2 0 1. So 0 2 0 2, we have to come to 0 2 0 2. We are at 0 0 0 0. We have to come at 0 2 0 2. Now from here I can go to 0 1 0 0. Then I can go to 0 1 0 1. Then I can go to 0 2 0 1. Then I can go to 0 2 0 2. Yeah. So from this to this one. Acha, wait. I also have to take care of these, right? 0 2 0 1. Yes. So this is not allowed. I cannot be in this state. 0 1 0 1 is also not allowed. Okay. Yeah. That is an important constraint to keep track of the dead ends. So should we simulate all the possible ways basically when I am at this 0 0, what all choices do I have? I have a choice. Now when I'm at 0 0 0 0, I also have to figure out which of these can I rotate. I can rotate anyone. So I have choice for all of the positions. Also I can rotate in two directions, either left or right, which means either the value will decrement from 0 to 9, or it would be like, sorry, from 9 to 0 or 0 to 1. Something like that. Yeah, let's do right. From 9 to 0 or 0 to 1. Okay, so should we go ahead with this approach? Approach. Okay. We have this. Let me check the topic tags. It would give me some idea where to look at. BFS. Okay, okay. BFS is a good thing. So we are here and we have to move to this state without going through the block stage. Okay, so this state is a mode, and whenever we are changing, like we are doing like plus minus one, that we are considering an edge. So we have to start BFS from this node and we have to end BFS when we reach the target. Great, great, great. Again, it is saying minus one when our target is blocked, or basically I cannot reach it. Whenever I cannot reach it, I'll have to return minus one. Yeah. For any particular node, we have 8 possible scenarios because we can move any of the nodes and we can move any of the wheels and in 2 directions. So we have 8 possible neighbors if we talk in terms of a graph. Okay, okay. Let's try solving this first. Uh, let's do one thing. Yeah, for BFS, I'll need a queue. So let me just maintain a queue linked list, and I'll add the initial state of 0, 0, 0. Okay, and now, let's do BFS. Is also I need the number of steps, right? I can add the number of steps in here, or let's maintain a separate variable int count is 0, which we will return at the end. So okay, right now we are at 0, 0, 0. Excuse me. So its size is this, and now for all the nodes present in the current level or in the current state of the queue, we will what we will do is we will hold the queue one by one. If we have reached current or equals target, we can just return count. Otherwise, let's go for all the 8 directions we are talking about. So, okay, I need a neighbors something, right? I need a neighbors stuff. So we have 4 neighbors, right? Okay. How to maintain the neighbors? So actually, neighbors would depend on the on the this uh, on the current state, right? On the current node. So if I have some neighbors, it will depend on the current code, and we will return all the neighbors. Okay. So we'll have 8 neighbors. Let's calculate them. String. This is my result. New string. Or let's use a list of strings. Result is equal to new array list. Yes. So here we are. Yeah. Okay. Getting this. Now we will iterate through the code. Let's just make an array and we'll iterate through it. I0 will have only 4 characters which we are sure of. Yeah, and current is error of I. Now, now, what we can do is, basically if we are at 0000, for every, basically for every particular character as well, we have two different ways. Like we are starting from 0000. Let's see that, let's say that I am updating this one, this particular thing. So what it could be? It could be that 9000 or it could be 1000. So I have to take care of both the stuff. Or okay, I have to take care of both the stuff. Okay, let's take care of both the stuff. So this is 0000. Hmm. Let's see. Wait. Current is uh, let's also take the directions so that we can be sure where we are moving. Okay. It's either one basically means moving one step ahead, minus one means moving one step back. Okay. And this is the current stuff. Now, yeah, we have two directions as well. So what we will do is int widget would be whatever the current is suppose zero. Okay. Current is zero. Now what I'm saying is now since current is a character, I'll have to do this current and zero to make it a digit to handle it as a digit plus one. So if it is zero, okay, we get zero and we have both plus one would give us one and we also need to take care of minus stuff. So for that we will add this mod 10, which means that if we have minus one, it gives us 0 minus 1 plus 10, which is 9, so we can just do mod. So this wrapping thing is taken care of. And now in error of I, basically we have updated it. So we can say this and our result will have this particular stuff because yeah. Similarly, um, we can yeah. And now let's just update it back so that we can go through the other stuff. And after all of it, we will return result. Now where was we came to this because we need the neighbors, right? We need the neighbors. So here we are saying for string adjacent, adjacent in neighbors of current. So okay, I have to I have to ensure that it is not a dead end. So let me do one thing. Let me add all the dead end in a set so that it is easier for us to search on it. This and arrays dot as list dead ends. Arrays dot as list dead ends. So I'll check here if not dead dot contains addition. Also like we should not be looking across the same. Like if I have moved from 0001 to 0002, we should not visit it again. So we also need a visited set, let's say. So let's make a visited set as well. This would also be a hash set, not initialized by anything. And here I say and not visited dot contains this. Then only I can move this, right? And when I move to it, I'll add it to this and into.offer. I will leave that note. That's it. After doing all of these things, I can say my sorry, our account can be increased. It is current visited because I have made this. That is why. अरे यार. What is the issue? Output is this. We expected a -1. Why? Why? Okay. Only this is the correct condition, right? Here we should just put on -1. That is the correct condition where we are able to reach our target. Okay, let's submit this. But let's also go through our solution again. What we are trying to do is, oh man, presents. Okay. This is a edge case. If edge case is that if no if dead contains if dead dot has dot contains 0000, we should just put a -1 and stop our code right there. Essentially, when finding this, we have two directions and all the four array values. So we are taking the first direct. So I'll get code as 000. Okay, I prepare an array which is 0000. But all of these are characters. Okay, and I have this direction. Current is saying about a particular index value. So this is not like essentially current is only zero or any one particular character. And then we look for all the two directions. Okay. Now current minus zero, this we have done so that we can convert this character to a character to a integer. Okay, minus zero character to integer. Okay, now it's converted to integer, so we have zero, whatever number, and then we add the direction. Now with plus minus one, uh, we need to manage the left hand side as well, or the wrapping around part as well. That is why we are taking plus 10, okay, and mod 10. Okay, now we'll have to add this state 1000 or 90000. So to add that state, we are just doing this thing. There is ARR of I, we are adding this character. Digit is integer. So yeah, integer to character conversion and result dot add this, and then we are resetting it because our calculation should be on this the existing or the original code only. So yeah, okay, this is a good question. We should revisit it in some time. Let's just add it here. Let's go. Well, only last question is pending. Let's just solve this last one question and we will be done. Okay. What is the question? What is the question? Wait, 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 wait. I I have closed my streaming window by mistake. Let me just open it again. YouTube Studio. Where will I get my streaming window? I've closed it by mistake. Let's go to the question. And then maximum sum circular sub array submissions. I have never submitted. Okay, 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 okay. Uh, where can I see? Where can I see my live stream? Not sure. Or I am live. Go live. I am live. Live stream. Yeah. Okay. 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 I'm connected. I'm connected again to the to this. Okay. Sure. Let's continue. Let's continue. Given a circular integer array of length n, then the maximum possible sum of a non-empty subarray of nums. Maximum possible sum of a non-empty subarray of nums. A circular array means the end of the array connects to the beginning of the array. Formally, the next element of nums of I is nums of I plus 1 mod n. Nums of I plus 1 mod n. Okay, and previous element is this. Okay, only include each element of the fixed buffer at most once. Formally, for a subarray. Okay, 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 okay. Maximum sum circular subarray. So now the positive, basically, it can contain. If you remove the circular stuff and just think about the maximum sum subarray, then it is cadence algorithm. Okay, but since we have a circular part as well, let's think about it in this way that see, if we are if we are utilizing this stuff like in here, if you see this 5 and this 5, that is giving us the maximum sum. So basically that means that if in case in terms of a simple array, if you think, we have to remove the smallest subarray, correct? So total subarray sum minus smallest subarray sum. In any ways, anyways, we would be needing the total sum. So let's just calculate the total sum. Okay, now, but this now we have to calculate the maximum sum subarray as well. What is the maximum sum subarray? It is the cadence algorithm. Do I remember it? Of course not. But we'll have to utilize the cadence algorithm. Cadence algorithm. How to use cadence algorithm? Cadence has a property that basically in cadence we maintain two variables. We maintain two variables. One is the current sum. Let me try solving it. Okay. So in cadence we have two variables. One is the current sum. Basically start with this, and one is the max so far, for which let's say we are taking the main value and then we iterate through the array. So we are at 1. We are at 1. Every time we'll update current sum. Basically we'll check that if current sum plus nums of I, or wait. What we let me try solving it on pen paper first and then I'll come to the code. Yeah, okay. So we have 1 minus 2, 3 minus 2. So current I'm taking as 1, max so far will be 1. Now after that we get -2. So current decreases. Yeah, okay. So that basically says that if current decreases, then we reset the current to 0. That is what the cadence algorithm states. So we will do current sum plus equal to nums of I, okay, and for max so far it would be max dot max of max so far and comma current so far. So here the logic is that if after adding the current sum decreases, so current sum will only decrease. So if there is a number x and if I add a y to it, this means we have a current sum. So let's see, suppose in here we have 1 and then -2 is coming. When 1 is coming, current sum is increasing. But when -2 comes, current sum decreases. Current sum decreases. So if we have something like -1, then also it will decrease. But if we have something, so a number will obviously a summation will only decrease if the incoming number is negative, right? If the incoming number is negative. So we'll check this. If nums of I is less than 0, if the incoming number is negative, then just reset it to this. Otherwise, let's do this. Now after this, I am returning max so far. I'm only checking whether my cadence is working or not, and after that we'll continue. So my cadence is not working. My cadence, acha, okay. Current sum plus equal to, it won't be plus equal to. Basically, we are saying if number is negative, we are resetting it to 0. If number is not negative, then, then we are doing current sum plus num of I, right? Yeah, correct. So this should pass because in this we have a simple subarray like 3. In this subarray -2. So yeah, since here we are utilizing the wrapping up property, that is why we are unable to solve it. What is the answer coming here? Achha, okay, this is basically an edge case of cadence algorithm that if all elements are negative, then it should return the smallest negative element. So that is one edge case of cadence algorithm. Okay, so this thing you can actually solve by simply checking if max so far is still 0, max so far is equal to 0, that will tell me that I have to return. Basically, if it is, oh, sorry, it is not 0, it is integer. Yeah, it would be 0 because we are doing this calculation. Then we can return the smallest element of the array. But okay, let's also take care of the this thing. The other approach which we have to handle for wrapped subarray. So there, the same thing would be required, but here we will add some current and some 0 as well, and a string with my string, I think. No, the string is fine. Okay, so let's continue. Yeah, here this is fine, and then so far would be map.min of then so far comma current then sum. Yeah, so after we are done with all of that, we'll check. Acha, yes. We have the total sum, right? So we can check that. If total sum is less than 0, total sum is less than 0, we can return max so far because max so far would be 0. Sorry, if all numbers are negative, we are returning max so far. Our max so far, wait, acha, will come to this logic. First, what we have to do is we'll either return max of r, max of max of r, or for the wrapped step, we do some minus min so far. Right. This is what we will do. So here we should take, basically we can write it in a better way, that we should take maximum of either the current number or current sum plus nums of I. Okay, same thing here. We should take minimum of either the current number or current min sum plus nums of I. And if max so far is less than 0, we'll return max so far. Okay, so we have solved all the questions. Wait, we have solved all the questions from this list. Okay, and yeah, uh, this should be it. This should be it. Should we solve any other question? Okay, okay. I think I'll wrap up this stream because I am facing some internet issues as well. So let me just wrap up the stream. Wrapping up the stream. Thanks for watching. Okay, thank you everyone. So I'll just stop.